Okay, I'm just gonna go over the review sheet kind of quickly. Most of this you should already have done already. I'm giving you 2 days to do this review sheet, and I'm also going over this review sheet with you, so you should be ready to go by Wednesday. Number 1 through 9. Basically, what we learned in 7.1 was to look at the formula sheet and recognize the formulas quickly. So number 1, you see the sine of x dx, and you're integrating it, which is a negative cosine of x. This has no limits, so you have to put a plus c at the end. Final answer. Number 2, you integrate 5 of 5x plus 3 raised to the second dx. You recognize that this 5 is the derivative of the inside part, and we didn't learn the u substitution yet, so you should recognize that that 5 would go away if we actually did it. So it's 5x plus 3 raised to the third divided by 3 plus c. The quick way to check to see if you did all of these right on the test is you could go in the circle and you could find the derivative of this. You could find the derivative of this and see if it equals that, if you have time on the test. Number 3, 8x e to the 4x squared dx. Again, this is the derivative of this. Just like this was the derivative of that. So you're kind of ignoring the 8x because it's the chain rule backwards, so the final answer is e to the 4x squared plus c. Final answer. Just to show you on number 3 that we did it right, if they ask you to find the derivative of this, e is easy. You copy it down exactly the way it's written, and then you take the derivative of the exponent, and the derivative of 4x squared is 8x, and that's exactly what it is. Number 4, secant of x tangent of x minus e to the x. That whole thing is dx. The antiderivative of secant tangent is secant of x. The antiderivative of e to the x is a negative e to the x plus c. Final answer. Number 5, I like rewriting it as t plus, t, I don't know why I did tangent, t plus 5, all of that raised to the negative 1 dx, or dt, sorry. On negative 1, when you add 1 to it, ends up being 0, so you know it's the natural log, and put absolute value down. The reason why you put absolute value down, if you remember from algebra, is that you cannot have a negative log, so you should put it in absolute, because we don't know what t is going to be. And if t is a negative number, like a negative 6, which would make it a negative 1, you can't have that, so you have to put absolute values around it, because logs have to end up being positive. Number 6, that's integrate x to the negative 1 minus integrate x to the negative 2 dx. When you add 1 to that, it's the natural log of the absolute value of x, plus, you add 1 to that. If you add 1 to that, you get a negative 1, but you have to divide by negative 1 plus c. So the answer key is the natural log of the absolute value of x. 2 negatives equal a positive 1 over x plus c. Number 7, very similar, x to the 4th minus 4x to the 3rd dx. Final answer is x to the 5th over 5 minus x to the 4th plus c. Just add 1 to the x. Number 8, antiderivative of the cosine of x minus e to the x dx. The antiderivative of cosine is sine. Antiderivative of e to the x is e to the x plus c. And number 9, a negative 3 cosecant squared x dx. I'm going to drag the negative 3 out and just do cosecant squared x dx. That's a formula on your formula sheet. That equals a negative 3. This equals a negative cotangent of x plus c. And a negative of a negative equals a positive, so it's 3 cotangent of x plus c. Okay, very quickly, those are the first 9. And you should be pretty good at those for the test. So make sure you memorize your formula sheet. Okay, 10, 11, and 12, the only difference is they are definite integrals, which they have an ending to it. So for number 10, I'm going to anti-derive secant squared x, and I think most of you know that it's tangent of x when you do anti-derive secant squared x. You draw a straight line to show that you did find the antiderivative, and then go from 0 to pi over 3. You should not use a calculator. You should be able to know that that's 60 degrees. Opposite of 60 is the square root of 3, 1, and 2. The tangent of that picture is the square root of 3 over 1, which is the square root of 3, minus, and then you need to do the tangent at 0, which is 1, 0, which is y over x, which is 0 over 1, which is 0. And the square root of 3 minus 0 is the square root of 3. Number 10. You only need a calculator, I think, for the last problem. The only time you need a calculator is for the last problem. So, I think I'm only going to have you use a regular calculator tomorrow, because you could plug some of these in on your calculator and you could cheat and find the answer. So tomorrow, make sure you just have a basic calculator. As you can see, you don't really need a calculator until the last problem. So I'm not using a calculator at all. You can ask somebody in trig or college algebra, hey, can I use your calculator for 5th hour for 1 hour, and I'm sure they'll give it to you. So keep that in mind. I'll say it again, and I'll even post it to remind you. Number 11, I'm going to anti-derive really quickly. It's going to be x squared over 2 minus 1 over x when I anti-derive from 1 to 2. It's really important that you know how to anti-derive. You plug a 2 in, you get 2 minus a half, and I like writing that in parentheses because that's all for the 2 minus, and then you have to put the 1 in. Whoops, I made a mistake right here. It's supposed to be 1 half minus 1, because 1 divided by 1 is 1. 2 minus a half is 1.5 minus a negative a half. And 1.5 minus a negative of a half is 2. And the last one, number 12. X to the third over 3 minus x squared from 0 to 2. This one's a little bit easier because you only have to put the 2 in, because the 0 is going to end up becoming 0 when you plug 0 in for all the x's. So you have to plug the 2 in, and you get 8/3 minus 4. 8/3 minus 4 is the same thing as 8/3 minus 12/3. And 8/3 minus 12/3 is negative 4/3. Final answer. Okay, that's it for that middle part. Next part is 13 and 14. And all you're doing is, I'm just going to explain 13 and 14 to you. They want your graph to go through 0, 1. So you have to make a parabola going through 0, 1 and follow the slope field. And they want you to make a snake on number 14 going through 0, 1. I know it's hard to see, but there are dots at 0, 1. If you look at 13 and 14. So 13, here's 0, 1. You should have made a parabola because you followed the slope field. And number 14, there's a dot there, it's hard to see. And you should have made a snake by following the slope field. Okay, the next part, 15 and 16. Number 15, dy dx equals 1 plus x squared over 2. And they want you to use 0, 1. So all they want you to do is go backwards. They want you to integrate. The antiderivative of 1 is x. The antiderivative of x is x squared over 2. And the antiderivative of that is x to the 3 over 6. Because there's already 2 there, and you have to divide by 3, which makes 6. All your x's make 0, so y equals 6. You put a 0 there, you put a 0 there, and you put a 0 there. So pretty much this makes 0, but then on this side you have to put a 1, And you need a plus c, of course, at the end of this, just to show you when you anti-derive, you get x plus x squared over 2 plus x cubed over 6 plus c, and c is going to equal 1. All you have to do is, I wouldn't rewrite it on the test. I just go up there and erase the c, make it 1, circle it, save you some time on the test. And one more, 16, and we're done with this part. You anti-derive. Well, first of all, dy dx equals, and I like writing it as t plus 4 raised to the negative 1 instead of 1 over t plus 4. So when you anti-derive that and you add 1 to that, 0. So it's the natural log of the absolute value of t plus 4. And then don't forget your plus c equals y. In this one, the y is 2 and the t is a negative 3. And you get 2 equals the natural log of 1, because negative 3 plus 4 is 1, and the absolute value of 1 is 1 plus c. The natural log of 1 on your calculator is 0, so c equals 2. You could plug it into your any basic calculator and see that the natural log of 1 is 2. Again, save some time on the test. Take the c, erase it, put a 2 in there, circle it up there, and you're done with number 6. Okay, number 17, you're making a slope field. Number 17, you're making a slope field. And all you're going to make is an x and a y and the slope, which is y over x. Slope is y over x. And you're going to go 0, 0, 1, 0, 1, 1, 0, 1, negative 1, 0, and negative 1, 1. Where did I get those 6 points from? From the actual graph. That's where I got those points from. And basically what you have to do is dy dx is called the slope. Negative x plus y, that's your slope. And all you're doing is plugging the 0, 0 in here. And that's how we got 0. And then you plug 1, 0 into here. And then you plug 1, 1 into there, and so on, and it's going to look like this for your table. And then I'm not going to do them all. I'm just going to do maybe this one and this one. And you look at 0, 0, and it has a slope of 0, so I need what a slope would look like at 0. It would be 0. And then one more. At 1, 0, the slope is a negative 1. That looks like about negative 1, and you do the same. Obviously, this one's going to have a positive, steeper slope than the rest of them, because it has a slope. Okay, 18, 19, 20, and 21 is use substitution. So here's 18. There is no limit, so you can just start doing 3x plus 2 dx. You let u equal the innermost part of 3x plus 2, du dx equals 3, so du divided by 3 equals dx. I need to see that because we're using u substitution, and now all you're doing is substituting. You're going to integrate the secant squared, and 3x plus 2 equals u, and the dx equals du divided by 3. So our final answer is, I need to have a 1/3 in my problem from here. And the antiderivative of secant squared is tangent of the u, and the u in this problem is 3x plus 2 plus c. Final answer. Keep going, number 19. You see, I'm going to let u equal t squared plus 5 for this problem. Du dt equals 2t. So du divided by 2t equals dt. I'm going to integrate. I'm going to leave the t. I'm going to replace the t squared plus 5 on the bottom with u. And I'm going to replace the dt. I see I made a mistake. I have 2 dt's there, so disregard both of them. For one of them, I need replace the dt with du divided by 2t. The t and the t goes away, so I'm left with 1/2 integrating u to the negative 1 du. When you integrate u to the negative 1, it ends up being 0. So I know I'm doing the natural log, 1/2 the natural log of the absolute value of t squared plus 5 plus c. Just to explain something really quick, I would always automatically put absolute value, but on the AP test there might not be an absolute value for this problem, because whatever you plug in for t, it'll always be positive, but I would always use the absolute value, so just put the absolute value in there. Number 20, I'm going to let u equals the sine of x, so du dx equals the cosine of x, so du divided by the cosine of x equals dx. Again, use substitution, there's a 6, I'm going to bring it out. In place of the sine of x, I'm going to put a u, so it's going to be u to the third. I'm going to leave the cosine of x, replace the dx with du over the cosine of x. Goodbye to that, you're down to a more basic problem. It's 6u to the fourth over 4 plus c. The last thing you have to do is replace the u with the sine of x. So I would just write it as a parenthesis with the 4 divided by 4 plus c. And the last one of this type, 21, let u equal 2x plus 3. Let du dx equals 2. Du divided by 2 equals dx. I'm going to bring the 4 out in front. I'm going to replace the 2x plus 3 with u to the fourth. And then it's going to be du over 2, because that's what dx stands for. 2 goes into 4, 2, so you're going to have a 2 on the outside, u to the fifth divided by 5 plus c when you integrate u to the fourth. So my final answer is 2x plus 3 to the fifth divided by 5 plus c. Okay, that's it for that part. The next part is what happens when there's limits like a negative 1 to 1 and you're doing u substitution, pretty much the same concept. I'm going to let u equal the 4 plus r squared. Du divided by dr equals 2r. Du divided by 2r equals dr. So I'm going to leave the 5r, the 5r. I'm going to replace the 4 plus r squared with u to the second. I'm going to replace that, and then I'm going to simplify, and I'm going to have a 5/2 integrate u to the second du. Okay, I'm never ever going back to r's. If I'm never going back to r's, I cannot use my r limits. My r limits have to be changed. Very important that you do this. Really important that you remember to do this. You're going to put negative 1 in there, and you're going to get a 5. You're going to put a positive 1 in there, and you're also going to get 5. You can stop right here on this problem, because whenever you integrate from 5 to 5, the area would equal 0. Remember, if the numbers are exactly the same, that you would get 0, so you could stop in this problem. Okay, this one, the next one, you're not going to stop. I'm going to make it that you have to actually solve it. Again, you have limits, so you have to change your limits in a few minutes. I'm going to rewrite this as 5x plus 2 raised to the negative 1 dx. I'm going to let u equal 5x plus 2. I'm going to find the derivative of that, which is 5. Du divided by 5 equals dx. I'm going to substitute. In place of 5x plus 2, I'm going to put u to the negative 1. And in place of dx, I'm going to put du divided by 5, which ends up being 1/5. And I'm never going back to x's, so that means my limits must also change. When I plug 0 in here, I get 2. When I put 1 in there, I get 7. So that's my new limits And the antiderive of u to the negative 1 makes 0, so it's the natural log of u from 2 to 7. But don't forget about the 1/5, which we'll add at the end. Basically, it's the natural log of 7 minus the natural log of 2. And the rule says that there's a minus sign, that you can put these together, but divide 7 divided by 2, which makes 3.5. And then put the 1/5 as part of your answer, final answer. Okay, we just have a couple problems left. The next part is separation of variables. We have dy over dx equals 3xy, and I like writing the points as just 0, 3. dy divided by y equals 3x dx. I separated the y's and the x's. The dx and the dy have to be in the numerator. The other ones do not have to be in the numerator. After you separated, integrate both sides. When you integrate y to the negative 1, it ends up being the natural log of y. And this is 3x squared over 2 plus c. Once you get that, you have to use the 0 and the 3. It's the natural log of the absolute value of y, which is the natural log of 3. And you plug 0 in for the x, and you get c equals the natural log of 3. So now I have the natural log of y, absolute value of y, equals 3x squared over 2 plus the natural log of 3. I'm going to join these together on the same side because I'm going to use my natural log rule. The natural log of y minus the natural log of 3 equals 3x squared over 2. The natural log of y divided by 3 equals 3x squared divided by 2. There's a little e down there, so I can write this into exponential form. E raised to the 3x squared divided by 2 equals y over 3. Multiply both sides by 3 to get y alone. 3e to the 3x squared over 2. And the last one of this type, I'm going to bring the y over to this side, and I'm going to bring the dx over to this side. So this is what it looks like when we separate the x's and the y's. I integrate, that makes y to the second over 2. This makes x to the second over 2. Don't forget your plus c, it usually goes on the right-hand side. The points that we're using for this problem are 2, 4. In place of the x, I put 2, and I get 2 plus c. In place of the y, I put 4, and I get 8. So c equals 6. Replace it, y over 2 equals x squared over 2 plus 6. I'm going to multiply everything by 2, so I get y squared equals x squared plus 12. I need to get y alone, so I need to plus or minus the square root of x squared plus 12. Final answer. Now the last one, new page. The formula they give you is v equals v sub 0 e raised to the negative k over mt. They're telling you the initial velocity was 35, and they want to know how long it's going to take to get down to 5. So you're going to put 35 to 5 e. And they're telling you that the k is a negative 100, and the m is 1,000 t. And this is not a calculus problem. This is more of a college algebra problem. I'm going to rewrite it. Well, you know what I'm going to do? I'm going to divide both sides by 35 first to get e alone, which gives you 1/7 equals e. I like to reduce a negative 100 divided by 1,000, which is a negative 0.1 t. You don't have to do that, but I like to know that a negative 100 over 1,000 is a negative 0.1. And then all you have to do is, in order to solve for t, you ln both sides. So it's going to take the natural log of 1/7, take the negative 0.1 t, natural log of e. This ends up being 1. So on your calculator, this is the only time you need to use a basic calculator for the test tomorrow. the natural log of 1/7 on your calculator divided by negative 0.1 should end up being t equals 19.5 seconds. And the last one, how long will it take to coast from coast to complete stop, 35e to the negative 0.1 t, and then don't forget your little dt at the end, showing me that this is the velocity that they gave us at the beginning. If they're asking you how far it will take, when you integrate says to find the area. It says to find the distance. It also means to find the position. When you integrate, it means you're going back to distance, area, or position. And underneath the integration sign is velocity. So, if they want you to know how far means distance, and all we're going to do is integrate. I'm going to pull the 35 out. It's just going to be e to the negative 0.1 t divided by a negative 0.1, because you have to take and divide out the derivative of the exponent. And then that's the antiderivative of that, put a plus c, and you could set it equal to y like I've been doing. And if you're coming to a complete stop, the point you're using is 0, 0, just like we kind of did on the section before this. 35e to the negative 0.1 times 0 divided by negative 0.1 plus c equals 0. This part right here is going to e to the 0 ends up being 1. So it's 35 divided by, sorry, I missed the negative 35. Where was the negative 35? I copied it down. When I anti-derive that, oh, there's the negative. It's there. 35 divided by negative 0.1 ends up being a negative 350 plus c. So c must equal a positive 350.